Here we are going to see about ultrasonics, and the course code for this ultrasonic topic is 7BPH1C1, and the course name is Properties of Matter and Sound, and which is in the semester 1, and which is a core paper in the Allahabad University. Here we are going to see about ultrasonic waves. We know that sound is nothing but it is a energy which produces the sensation of hearing. That is a definition for sound. And sound can be divided into three categories or three types. That is infrasound, audible sound, ultrasound. Then there are this sound can be divided according to the basis of its frequency. So you know, here infrasound will have the low frequency, and the audible sound have the frequency between 20 Hz to 20,000 Hz, and the ultrasound has a frequency more than 20,000 Hz. So that is called ultrasound. Then waves whose frequency is more than 20,000 Hz are called ultrasonic waves. Here you can see, here this is the infrasound, and which the the wavelength will be more, at the same time the frequency will be less. And this is the audible range, sound, because its frequency is 20 Hz to between 20 Hz and 20 kilohertz. And here the more than 20 kilohertz are called ultrasound. And you can see here the picture. You can see that bat is finding its obstacle by producing and hearing the ultrasonic waves. So the bat can only produce and hear the ultrasonic waves. The human being cannot hear the ultrasonic waves. So the bat can find its obstacle by ultrasonic waves. And similarly, here the dolphin can also find the fishes which are swimming inside the river water by using the ultrasonic waves. And here also the seashore can also be seen by this dolphin by the ultrasonic waves. So whatever obstacle present in front of these animals can see or can find out by using the ultrasonic waves. Then ultrasonic waves, in this class, ultrasonic waves, we can go and see about the method of productions, properties, reductions and applications. First we will see method of productions. What are the ways by which we can produce ultrasonic waves? There are three ways by which we can produce ultrasonic waves. One is a mechanical method. So the other name, a mechanical method, the other name is, the device name is Galton missile method. Then magnetic method. Using the magnetic method also we can produce ultrasonic waves, and the effect is called, and method is called magnetostriction method. And another one is electrical method. So in the electrical method also we can find that we can produce ultrasonic waves by the device called, or by the principle called, inverse piezoelectric method or converse piezoelectric method. So in your syllabus we are going to see about how to produce the ultrasonic waves in the electrical method, that is inverse piezoelectric method, that we are going to see now. So first of all, before going to see about the inverse piezoelectric effect, first of all we must know what is piezoelectric effect. If the piezoelectric effect is nothing but if one pair of opposite faces of a quartz crystal is subjected to a pressure, then other pair of opposite faces develop equal and opposite electric charges on them. Here this is a quartz crystal, and if you apply the pressure on top and down, that is to upper surface and down surface alternatively, if you apply the pressure on both opposite faces, then we can see the deflection in the galvanometer, or we can see a deflection in the voltmeter. So here we are applying the force, and here also applying force. Here we are applying the force from top to down, and here from down to top. So we are applying the force on these two surfaces. When you are doing this, applying the forces alternatively, then we can see there is a deflection in the voltmeter. So when you will get the deflection in the voltmeter? Only when there is the charges are flowing inside the wires or inside this device. So it means that when you give the pressure alternatively on top and down surfaces, here the charges are produced and the charges are moving through these devices. That is why there is a deflection. So whenever you apply the pressure, you are getting the charges on both sides. So this is nothing but piezoelectric effect. This type of piezoelectric effect will take place only in the certain type of crystals. That is quartz crystal, for example quartz crystal. So if this is a quartz crystal, if you take the quartz crystal and apply the force on top and down alternatively, you can see the deflection. It means that the charges are produced on the top and down surface of the quartz crystals. This effect is known as piezoelectric effect. Then the deflection of the electric charge developed is proportional to the amount of pressure or tension. That is, how much amount of pressure are giving on both sides, that decide the amount of deflection in the meters. So if you give more amount of pressure alternatively, more amount of deflection will take place in the device. So this is called piezoelectric effect. Then converse piezoelectric effect. This is nothing but that is inverse piezoelectric effect. So in the piezoelectric effect, we applied the force, and because that we are getting the charges. But here we are giving the charges alternatively on both the top and down surface of the quartz crystal, which is cut perpendicular to its optical axis. So when the two opposite faces of the quartz crystal, their faces being cut perpendicular to the optic axis. That is very important. So optic axis is nothing but if you pass the light rays through particular direction in the quartz crystal, there will be double refractions. So in one particular direction, the double reflection will not take place in the quartz crystal. That is called optical axis. So we have to cut the quartz crystal in the perpendicular to the direction to the optic axis. So you have to, this is a quartz crystal which is cut perpendicular to its optic axis. So we are taking this quartz crystal and we are applying the force both top and down surface of the crystal charges. So we are applying the positive charges here, we have negative charges here. That is, it means by means of connecting the external power supply. So this is external power supply, and here here positive charges are applied and here negative charges are applied, and alternatively. So when you apply the charges on both sides, there is an increase or there is a there is a pressure produced in the top surface and down surface. That is, elongation and contraction will take place. When you apply this one here, when the positive charge is here, in the extension elongation will take place. So the surface will elongate little bit in the upward direction. At the same time, this down surface will also elongate in the downward surface little bit. So when you apply the positive charge, negative charge here, there is elongation. At the same time, if you apply the negative side this side and here positive side, then there will be a contraction on both sides. So if you apply the alternative, if you apply the charges both top and down surface alternatively, then there is an alternate elongation and contraction of the top and down surface will take place. So top surface increase agum, top surface down surface elongate agum, then contract agum, elongate agum, contract agum, elongate agum, contract agum. So appadi irukkrappo that is pressure creations will take place. So stress and strain will take place. The quartz crystal will continuously contract and expand. Elastic vibrations are set up in the crystal. So crystal will be it will be oscillating. It will be keep on oscillating according to the our frequency of the alternate source. So the crystal will be vibrating up and down. It will be vibrating up and down, and because of that, so it will vibrate with some particular frequency. When this frequency is equal to the natural frequency of the crystal. So each crystal, the molecules which are present inside each crystal will be vibrating by its own frequency. When this elongation contraction, the frequency of the elongation contraction is equal to the natural frequency of this quartz crystal, automatically the ultrasonics will be produced or will be sent out from the crystal. So that is the principle. So here this is a quartz crystal, and this is cut perpendicular to this one. We are keeping inside these electrodes. This is a positive electrode, negative electrode, and this will be here positive, here negative. Then after some time, after a fraction of a second, this will be negative and this will be positive. So alternatively, this A and B plate will be getting positive and negative, and there will be elongation this side. That is elongation and contraction. Elongation, contraction. When this elongation, the frequency of the elongation contraction is equal to the natural frequency of the crystal, when both are equal, automatically it will start emit the ultrasonic waves. So this is, so here the principle, what here principle is given. By what principle the ultrasonic waves or the piezoelectric crystal, piezoelectric oscillator, we can say this is a piezoelectric crystal, and the device which is connected in the electrically, that is called piezoelectric oscillator. So piezoelectric oscillator will produce the ultrasonic waves. Inside the piezoelectric oscillator, the crystal is there, quartz crystal is there, and quartz crystal we are giving alternate for charges by which we can produce by which it produces the ultrasonic waves. So if the frequency of the electric oscillations coincides with the natural frequency of the crystal, the vibration will be of large amplitude and the ultrasonic waves will be produced. And here there is a construction. So this is a electronic circuit diagram to produce ultrasonic waves. It is called piezoelectric oscillator. Here the quartz crystal is kept between the two plates, and this is connected with one coil L2, and here L3, and here L1, and L2 is there. This is C1, L1 coil and C1 coil. This is one tank circuit, and this is a transistor, and here it is a key, and this is a hydrogen battery. Battery is connected, and this is emitter is earthed. So this required circuit diagram to produce ultrasonic waves, in the method of piezoelectric oscillator method. So here this transistor is base tuned oscillator circuit. This circuit is a base tuned oscillator circuit. A slice of quartz crystal is placed between the metal plate A and B so as to form a parallel plate capacitor with a crystal such as dielectric. So this is a capacitor மாதிரி act பண்ணும். இது வந்து dielectric. So இப்போ இதில் வர்றது இப்போ ஃபர்ஸ்ட் என்ன ஆகும்னா இது ஸ்டார்ட் இந்த சுவிட்ச் ஆன் பண்ணுவோம். Electric charge will be passing through this one, and the transistor will be acting, and here this charge will be here on tank. This is a tank circuit, and from here the charges will be transferred here, and the charge A and B will be the charges will be stored in A and B. Since it is acting as a capacitor, charges will be stored for a little time, then it will be transmitted towards this one, and it will, when we apply the charges here, it will elongate and contract, and this frequency we can change voltages and current by which we can change the frequency of these charges produced on the A and B, plate A and B, that can be changed. So by which we can produce the ultrasonic waves. Then properties of the ultrasonic waves: they have high energy content. They are they are having more energy than ordinary light waves. Light waves would have energy அதிகமா இருக்கு. Just like ordinary sound waves, ultrasonic waves gets reflected, refracted, and absorbed. So like ultrasonic waves get reflected also. It will reflect by sonar. You must have heard about sonar, sound navigation and ranging. So sonar is a device to find out the obstacles just passing the ultrasonic waves by the echo method. Then it can be refracted. Refraction is nothing but it will be deviated from its path. So refraction will also take place, and sometimes the ultrasonic waves can be absorbed also. Then they show negligible diffraction due to their small wavelength. Hence, they can be transmitted over long distance without any appreciable loss of energy. They produce intense heating effect when passed through a substance. So as I told you, since it is having high energy, when it is passed through the substance, it will produce a heating effect. If an arrangement is made to form stationary waves of ultrasounds in a liquid, it serves as a diffraction grating. So I think you must know what is the meaning of grating. Grating is nothing but lines, continuous lines drawn to pass light rays. So I mean straight lines, very close to straight lines. Grating plate will be there, a glass plate with no. The glass plate we connect it here, but there are so many lines have been drawn, and each each line will act as a obstacle, and when the light is made to pass through that one, that is monochromatic light is made to pass through, or even white light is made to pass through that one, they will be diffracted by the straight line, by the lines. It's the line, and by which it will produce a diffracting effect. So, and here how the light is doing diffraction, similarly In the ultrasonic waves also producing the diffraction effect in the liquids. So the liquid layers will act as a grating element, and this is called acoustical grating. So these are the properties of ultrasonic waves. Then what are the advantages and disadvantages of the ultrasonic wave? We will see. That is, first advantage is ultrasonic frequencies as high as 500 megahertz can be generated. So using the mechanical method and the magnetic method, we are able to produce only 300 kilohertz ultrasonic wave, 300 kilohertz ultrasonic waves. But using the piezoelectric oscillator, we are able to produce high frequency ultrasonic waves such as nearly up to 500 megahertz can be generated. This is one advantage. The output power is very high. It is not affected by temperature and humidity because since its frequency is very high, automatically the energy will be also very high and power will also be very high, because E is equal to h nu. You know the formula, that is E is equal to h nu. If nu is more, automatically energy will be more. When the energy is more, the power will also be very high. So that since the power is very high, it will not be affected by that. Ultrasonic waves will not be affected by any temperatures and humidity. ஸோ அதாவது வெயில் காலத்தில் வந்துட்டு அல்ட்ராசவுண்ட் இது டிவியேட் ஆகும், ரொம்ப ஹியூமிடிட்டியில் டிவியேட் ஆகும் அப்படின்லாம் கிடையாது. ஸோ அல்ட்ராசவுண்ட் வேவ் வில் கோ இன் அ ஸ்ட்ரெயிட் லைன் even with the temperature is very high and humidity is also very high. Then it is more efficient than the magnetosection oscillator. As I told you, in the mechanical method or the Galton vessels or in the magnetosection method, this method, that is piezoelectric method, will give more energy and more high frequency ultrasonic waves. That is why it is more efficient than the magnetosection oscillator. The breadth of the resonance curve is very small, so we can get a stable and constant frequency of ultrasonic wave. That is very important point. That is, if you want to use ultrasonic waves in any place, the frequency must be constant. So it should not be variable one. It should be a constant and stable. It should be stable always. So such a stable and a constant frequency of ultrasonic waves can be obtained by using these piezoelectric method, piezoelectric oscillators. Okay. Then what are the disadvantages? If you see the disadvantages, there are two disadvantages. The first one is the cost of quartz crystal is very high. So quartz crystal is a basic part, a very important part of the piezoelectric oscillator, but the quartz crystal is very high costly, very high cost. Its cost of quartz crystal is very high. That is one of the disadvantage. Then second one is cutting and shaping the crystal is very complex. So I told you, the quartz crystal must be cut. So in order to use quartz crystal to produce ultrasonic waves, the first condition is it should be cut in the perpendicular to its optic axis. So first of all, you must know in which direction it is having optic axis, and you have to cut the quartz crystal in the perpendicular direction of the optic axis. And shaping the crystal is very complex. So these two are the disadvantages in the piezoelectric oscillators. But if you neglect about these disadvantages, then it will have more energy, and this oscillator can produce a high frequency ultrasonic waves. So this is what we are seeing here.